Okay, time for part 2. Okay, second of all, to find an equation, that's supposed to be say and, equation for function g, switch the x and y values in function f to solve for y. Now, this is the way to find an inverse function if you are already given the equation. So let's go ahead and do what they said. They want us to flip the x and y values. So I am going to take my domain and I am going to flip it with my range. So in order to do that, I am going to write x equals 3y plus 6. So to find an equation for function g, switch the x and y values in the function f and solve for y. So I flipped my x and my y, but now I need to solve for y. In fact, what that means is I need to get y by itself. So I have to undo this equation. Now, in two-step equations, remember we always work with the constant first. I want this to be a 0 because I need to get y by itself. And so in order to make the positive 6 a 0, I need to use a negative 6. Then this turns into a 0, and I don't have to worry about it anymore. But whatever I do to one side, I have to do to the other. So I'm going to minus 6. Now, as a mathematician, I always rewrite because this starts to look messy and I need to understand what's going on. So I'm going to write x minus 6, because I can't combine those, equals 3y. Now this is a 0, so I no longer need to write it. Now the next step is to get y by itself. Remember, that's still my goal, get y by itself. So I need to make this coefficient a 1. I need to turn this into a 1. So the best way to turn something into a 1 is to divide it by itself. Now division works here because this is 3 times y, and dividing by 3 is going to undo the work. Now remember, any number divided by itself is a 1. So this is now a big, huge 1, and I no longer need to write it. So it is now a y. But I divided this side by 3, so now I have to divide this side by 3. So my answer, my new inverse function, is x minus 6 divided by 3 equals y. Now, I want you to remember that as a mathematician, we can change the direction of this. This says y, so I can write y, and then x minus 6 divided by 3. These two are the same thing. I just want the y in front. So now what they want us to do is they want us to graph f and g. So in order to graph f and g, first of all, let's go ahead and do function f. Function f has a y-intercept of 6. And if this is not familiar to you, this is why I have us working on some of the prior knowledge. My slope is 3 over 1. So that means I'm going to rise 3, run 1. So rise 3, 1, 2, 3, run 1. Now, since this is going off the graph, I can actually do the reverse. So my slope is 3 over 1, which is the same thing as negative 3 over negative 1. So I can actually drop 3 and go backwards 1. Drop 3 and go backwards 1. Because remember, a negative divided by negative is a positive. It just helps me with my graphing to know that I can do that. Okay, so I'm going to sketch my line. Now, to go ahead and graph g, the function of g, it is going to be a little bit more challenging because we do have a fraction here. So I'm actually going to pull over a piece of paper, make myself a graph paper or a graph. So let's pull this over. So make myself a little table here, and I have x minus 6 divided by 3. So I'm going to choose values. So notice I have a 6 and a 3. I'm going to choose values that make it very simple to solve this. So I notice that if I choose 3 as my x, I'm going to substitute 3 minus 6 over 3. Now 3 minus 6 is going to be a negative 3 divided by 3. And negative 3 divided by a positive 3 is going to be a negative 1. So that's my first point. It'll be 3 comma negative 1. So I'm going to come over here, go to 3 and negative 1. Okay. My second point, let's go ahead and do a 6. Now let's do a 9. Let's do a 9. Okay. Nope, we can't do 9 because look at this. Well, we can. I'll show you how to sketch it. I want you guys to know you can just do rough estimates. Okay, so I'm going to substitute in 9 minus 6 divided by 3. 9 minus 6 is 3 divided by 3. 3 divided by 3 is 1. So now I have a point at 9 comma 1. So I'm going to go to 9, which is a little bit off, and then up here, up 1. Now, if I go ahead and sketch this, and I don't have a ruler, just use any straight edge or sketch it in. And notice that's my f of g, and this is my f. And I can actually test it. I get another piece of paper here. Here's my line of symmetry. I'm going to draw in f, and if I pick this up and flip it, there is my line G. So it did match up perfectly. So let's see if we've done everything here. We graphed our functions. Our line should reflect over y equals x, and they did. So what is the point at f negative 1? So let's find f. At negative 1, it is a positive 3. What about g? When g has an x of 3, g has an x of 3, oh, look at that, it's negative 1. So we did this correctly because these are the inverse points. Okay, one more time. Let's go ahead and take a look at D. How else can we look at inverse functions? Does this graph pass the vertical line test? So let's look at f of x. Here's f of x. Now this is a term from integrated 1, so if you don't remember the vertical line test, what that means is I need to make sure this is a function. And how I test that is if I move my pencil across, it only hits one part of the line at a time. So notice I'm starting on the left, I'm moving my pencil, and no matter where I stop, there's only one part of the line that's on the pencil. So this does pass the vertical line test. Now they want us to sketch a graph of f of x that reflects over the line of y equals x. Now again, I'm going to get some more patty paper. And we're going to do that reflection. So I'm going to lay this down. I'm going to sketch my line of reflection. And I'm going to flip it. And I'm going to draw my graph. Now remember, to do a reflection, I literally pick it up and I lay that line of symmetry right back down over where it was. And then I sketch it in. So since I wrote on the other side of the patty paper, it's going to transfer. This is really cool. Watch this. Look at that. You can kind of see it, right? So I'm just kind of sketching it. There we go. Now I have reflected it over the y equals x axis. Now they want us to see if it passes the vertical line test. Now I want you to notice as I'm going from left to right, oh, what happens right here? Notice that my pencil is touching 2 points of the line at the same time. So this is not a function. Not a function. Let's try that with our graph g of x. As of g of x, it does pass the vertical line test. Look, no parts of the line. Only one is touching the pencil at a time. Now let's go ahead and flip it. Let's find the inverse. I'm going to sketch in my line of symmetry. I'm going to sketch in the line I want to reflect. I'm going to reflect it right at that point. And I'm going to, oops, do you notice what happens? Sometimes your paper flips, so make sure you line up that line of symmetry. Now I'm going to draw my line in. I can kind of see it. It goes right there. Don't worry about it being too straight. And now they want us to look at, does the reflection pass the vertical line test? If I move my pencil along, it does only touch 1 point at a time, right? Here's our points. It only touches one at a time. So this one is a function. Okay, that is the notes taking for today, and then we are going to start an assignment.